Okay, so this is today's lesson. So you obviously need to be writing stuff down in your books as you're going through this. And at the end, there'll be a question which I'll be expecting you to send through to me as a picture or as a Word document, however you want to do it. Um, but we'll get started straight away. So start a question is asking which type of radiation is most dangerous and why. So is it alpha or is it gamma? So if you want to have a think about that and maybe write an answer down that you think it is, and then when we've written the title down and stuff, we'll go through that. So think what you think, pause it if you need to, and then write down what you think. Right, when you're ready then, this is your title, Dangers of Radiation, and the dates, put your date and stuff down today as well, whatever date it is when you're watching this. Um, so we're looking today at why is radiation dangerous and how can we deal with it? And we want to know how it can damage your cells. We want to compare hazards of contamination and radiation. Sorry, that should say irradiation. And we want to suggest how we could minimize damage from different radiation sources. So, looking at alpha and gamma, we cannot say which one of them is more dangerous. Really important because a lot of people just say alpha's most dangerous or gamma's most powerful, something like that. But gamma could be the most dangerous because it's the hardest to stop, it's the most penetrating. But you could also say alpha is the most ionizing. And we think about what ionizing means, okay? And I want you to have a go at what you think it means, ionizing, and basically talking about how does radiation damage your cells. So if you can think about an answer, okay, which one do you think is correct? Just keep it to obviously. Normally you'd tell me what you think, but obviously you can't. So just keep it to yourselves for now. Um, and I'll go through what is right and wrong. So if you're looking at which ones of these are correct, so it crashes into them, causing it to burst the cells. That is completely false. That is not right. It strips electrons off the outer shells of atoms. That is true. That is what radiation does. That is why it's called ionizing, okay, because it turns it takes electrons away, turning atoms into ions. It causes DNA to mutate, which is also true. And it absorbed by cells, causing them to become radioactive as well, which is false. If you get radiation damaging your cells, you don't become radioactive yourself, okay? So, should be like this. So the first one and the last one are false, and the middle two are true. So we're going to go a bit into those false ones and say why they're false. So, sometimes people think that radiation causes damage by literally crashing into the cells and exploding them or something like that. And it's not like that. So the alpha particles, even though they're by far the largest type of radiation, they've got a mass of 1 times 10 to the 15 times less than a human cell. So basically, that's like if a elephant was hit by a fly. Okay, it's not going to cause much damage. That's not how they damage your cells. It's not to do with just literally bursting into your cells and damaging them. It's not about that. The other suggestion, it was absorbed by the cells because from radioactivity. It's not that. So radioactivity is caused by isotopes which are unstable. So unless you have unstable atoms in your cells, which some of them are, we've looked at that before about background radiation and stuff, the radiation itself is not unstable. Okay, so it cannot make your cells radioactive. So it doesn't make your cells radioactive. It doesn't cause you to become radioactive if you've been exposed to radiation. Right, moving on. So these two together should make a correct answer. Okay, so when radiation comes into contact with atoms, the electrons can be knocked off the outer shell of the atom. We call this ionization. If these atoms are part of DNA, it causes the DNA to mutate, causing cancer. So basically, if you've got your atom, okay, and you've got electrons in your outer shell, so let's do your nucleus in the middle and your electrons on the outside. So we've got your nucleus in the middle, the red dot, and we've got some electrons orbiting in your shells around the outside. So just a little dot for your electron. Right, what basically happens is, so say we've got a gamma wave, and the gamma wave would come along, and it would crash into your electron, and it would knock it out of its outer shell. Okay, this causes damage. If this hits your DNA, this causes damage to your DNA because it's mutating. It causes your cells, the atoms inside your DNA, that code that tells you what your cells are supposed to be, causes that to all get jumbled up. So if you knock that electron off the outer shell, it can damage your DNA, mutate your DNA, and it can cause cancer. Right, so I want you to try and, in your own words, describe how radiation can damage cells. So if you need to go back a little bit in the video to watch that little bit again, and then write your answer, you can do. So I want you to describe what radiation can do to atoms, explain why this is a problem in DNA, so what does it do to your DNA, and what problems can this cause for your body. So pause the video, write your answers down, okay, and then play it again to move on. Right, hopefully if you've done that, we can move on from there. So we're going to look at these two words now, contamination and irradiation. Now, normally I'd have to ask you to think about what these mean and discuss it and everything, but I'm just going to go straight into talking about them now. So contamination is the unwanted presence of materials containing radioactive isotopes. So an example of this would be something like this. So this would be contamination, okay? Because nuclear power plant dumping waste into a lake, that lake is now contaminated with the radioactive material from the nuclear power plant. Okay, so it's got stuff there that it doesn't want to have. Contamination can mean anything that has something there where you don't want it. But in our case, we're talking about specifically radioactive isotopes. Now, irradiation is a different thing. Irradiation is more like when a doctor would be too exposed to medical radiation. So this is irradiation, and that means when you're exposed to too much radiation, you're not becoming radioactive yourself, but you're exposed to too much radiation. So you've had too many alpha, beta, or gamma particles or rays hitting you, and then that's when your cells are being damaged themselves. So I want you to make sure you've got these definitions written down. So I'll leave it on this page for a second if you want to pause it and write those down. And you do need to know the difference between them. So contamination is where you've got too much of a particle in a place where you don't want it, and irradiation is just where you're getting exposed to too much radiation. So next thing we want to do, so pause it now if you want to write it down, and play again when you're ready. And the next thing we're going to look at is how we can prevent ourselves from being contaminated or irradiated. So in fact, sorry, let's do these first. So exam questions to answer. Okay, so any exam style questions I want you to take a picture of and send it to me. So if you can pause the video now, based on what we talked about with irradiation and contamination, can you write an answer for these exam questions? So pause it now and play it again when you're ready. So I will show you the answers for these ones though. So these are the answers we should have got. Okay, for 1A and 1B. Right, so we're looking at reducing the risk of radiation now. So if you think about some things that we might see day to day, if you go for an X-ray, a few things might happen. Number one, you might be given a lead-lined vest. Depends where the X-ray is. Obviously, if it's an X-ray of your chest, they're going to need to see that. But if you're getting an X-ray of your arm, like this little boy here, he might have been given a vest lined with lead, and that's to stop the X-rays, which are very similar to gamma rays, just a little bit lower energy, from going into his vital organs and causing him some serious damage. Also, when this doctor or this radiographer or whatever he is has finished, he won't stay in the room while the X-ray is taking place. He will leave, so he minimises his exposure. Also, he might have a little badge like this. So this is a radiation badge, this one at the bottom. So we're looking down at this thing now. So this here is a radiation badge, and it will have some photographic film inside it and inside different parts of it. And basically what this will do is it will change colour if the radiation levels get too high. So it will tell you, like, there's too much radiation, you need to get out of there now. Also, if it was a more serious thing, like nuclear power plant workers might have a suit like this, and if you notice especially, they've got breathing apparatus on. So that will stop any of the isotopes, the radioactive isotopes, the unstable atoms that are maybe in dust or in the air, from getting into their lungs and then causing damage from the inside. So they're completely sealed off from everything, and they might be lined with something like aluminium, So that would stop all the alpha and all the beta particles from getting through their suits and causing them any damage. Obviously, it's not going to stop gamma. To do that, you'd have to have a lead suit on, and that'd be very difficult to move then. So it's about practicality and weighing that up against your protection. So what I want you to do is, I want you to make a little power, what do you call this, like a spider diagram in your book. So pause it now if you need to write this bit down. And as we go through the next two slides, you're going to add some information. So shielding, we've just talked about the suits, okay? So radiation suits. Okay, and you might write about lines with aluminium, okay, to stop alpha and beta particles. So you write what you think is important up here. Exposure, you might talk about the doctor leaving the room, okay, or you might talk about wearing the badges so you know that like how much radiation you've had. So I'll go through the next two slides. You just be writing stuff down as you're watching. Okay, so shielding. So shielding is used to absorb as much radiation as possible, and it prevents it from reaching your cells. So the lead aprons would be a good example of this. And then the suits that we saw in the other slide would be also a good example of this. So they are there to absorb as much radiation as possible and to minimize it damaging your vital organs. So you might cover up just part of or all of your body and stop the radiation from getting through to you. Also, the doctor would leave the room, okay, and they would stand behind a screen. So that screen would absorb the radiation. So you might also remember watching, if you were here anyway, watching the little video about the person having the gamma injection, the radiation tracer, and as that radiation tracer is being moved around the hospital, it'll always be covered in lead to stop people, to shield people from the radiation. Now the other method is exposure or minimizing exposure. This is the best way to reduce damage. So simple as anything. If you don't want to get radiation damage, don't go near radiation. Okay, so people who work around radiation often have the badges that change colour if too much radiation is absorbed to let them know when it's safe. But other than that, they'll just try and spend as little time as possible around these radioactive isotopes. So they won't sit in a room next to them. The radioactive isotopes will be put in a lead-lined box somewhere and only brought out when they're really needed. Right, so you should have plenty down for your little spider diagram now, and I want you to use that to then answer this exam question at the end, okay? So I want you to read this yourselves. I'm not going to go through this. This is for you to do, and there's an extension there if you fancy doing that as well. So I want you to try and answer this in your books or on a Word document, and this is what you need to send me to prove that you've done the work today. Okay, so can you send that to me at the end of the lesson today, please? So pause it now because the video will end in a second, and just send that to me. I hope everyone's doing okay at home, by the way, and hopefully I'll see you next week. And make sure you've sent me this. Thank you.